Okay, so here we go, rolling down the road again, and you could say the old Willie Nelson tune. Isn't Willie Nelson on the road again? I can't wait to get on the road again. That's about all I know. But anyway, with that, I hope you've had the opportunity to see and visit family members that you haven't seen in a while. Okay, spend some quality time with them. Okay, because that's what this Christmas break should hopefully have been about. We briefly talked about the idea behind this is please take this opportunity seriously because, and when we do things like this, you are taking time away from other people. Okay? And I don't think it's really that hard, okay, to say, let him have his time, and probably about 35 minutes later, we're done. Okay? That gives you lots of time to have these sidebar conversations. Okay? But on a less serious note, I've got this T-shirt, okay, because it is a joke that has something to do with this, and I know that was one of your, it wasn't the random fact of the day, it was today's joke of the day, okay? That's why they say it, and you're going to say, oh, I heard that and I understand that, okay? It's the idea, what did I just point at? Okay? Don't trust atoms. Why?
Because they never touch.
No.
Oh.
Say that again? They make up everything, which is, that's a funny paradox because not only is that true scientifically, but it's also true in a humorous manner? Yeah, humorous way. Thank you. Okay? So, one of the things to think about, okay? Now, this was when I took organic and biochemistry from Augustana College. It was the professor there was talking about, and of course I'm, maybe in my 20s yet, maybe just turned 30, I don't know. Because my goal was to have 1 or 2 bites at medical school, okay? Didn't pan out. Yes, I was supposed to be a surgeon by now, but it just didn't pan out. That's one of the things just keep in mind. It's not that you have to have a backup plan, but don't get disappointed in the idea, this is what I wanted to do, and it's not going to work out, okay? Because look at this. I get to stand and watch you people grow up and mature, okay? That's a really neat concept. No, not concept.
Yeah.
Say that again.
A thing.
I don't want to use a thing.
That's really unique.
Just a really
A unique opportunity, okay? Because if I was a surgeon, would I be standing here?
No.
No, of course not.
You'd be standing in
You
front
would
of a
see
half
us
dead guy
when we're,
who you need to do a colonoscopy.
Okay? But regardless, okay, so with that, moving forward, you kind of threw me for a loop there. Oh, when it comes to, you may have to find something else to do. And when I had this organic class, he said, when it comes to materials, even like gasoline, we can make gasoline because we know that it's got 8 carbon atoms and it's got 16 hydrogen atoms, okay? But when you, now this is a little further down the road, but we don't say, well, you can, we said 8 carbon atoms, 16 hydrogen atoms. We can make that component, okay? But it's the different levels that we have. We say gasoline or gas as a very vague term. But really, do we know what this is actually called? Not gas. A little more, because fuel could be kerosene, could be diesel, could be gasoline, could be methane, ethane.
Petroleum.
Okay, you're getting closer. But here's your clue, okay? A stop sign has what shape? Okay, so this is octane, because when you go up to the fuel pump, you see 3 different grades usually. One's going to say 87, one's going to say 89, and the next one might say 91 or 92. Those numbers are significant because the higher that number is, the higher the octane rating. Okay? So the chances are people do get the cheapest one, which is 87% octane, okay? And then 13% heptane. What's that?
Why would you want to buy the more expensive one?
It burns cleaner. It burns, it's much better for your engine. It's just that it's more expensive. It makes it efficient too. And it probably doesn't burn or combust as hot. But this is what's inside your gasoline. So when we talk about these things, it's really important. We're talking about atoms that make up substances that affect your daily life. But back to Dr. Not Dr. Ellis. Dr. Earl. I knew it started with an E. Dr. Earl, he had made the comment saying, yes, you can make anything you want, but when it comes to this petroleum, why not make petroleum? It's much easier to refine it. It's much easier to take it out of the ground. We don't take gasoline out of the ground. What is it? We take crude oil out of the ground. And then it goes to a refinery where it gets heated up. And what happens, and this will make sense to you because it has something to do with earth science. Okay? From earth science, what is the most common gas in the Earth's atmosphere?
Gasoline. Fossil fuels. Carbon dioxide.
I might have heard it, but I'm not sure.
Carbon dioxide.
Say that again.
Nitrogen.
Nitrogen. Okay? So, do we breathe nitrogen? No. We breathe oxygen. So, if there is so much nitrogen in the Earth's atmosphere, why don't we breathe nitrogen?
Because plants.
Exactly. But why is it up further?
Pushed up by all the oxygen.
Look at the periodic table, and that will tell you the answer.
I told you.
Look at element number 7. What is inside 7's box?
7 is nitrogen and it's...
What's number 8?
Oxygen.
Okay. Now,
Heavy.
what are other, let's say, numbers that you see inside box 7? Don't do the plus and minus sign.
14.0067.
Okay. So then when you go to its next door neighbor, oxygen, what is its mass?
15 something something.
Okay. Now, one of the things that, these are mistakes that you're going to make. This is what is inside Earth's atmosphere. This, certainly this, but also that. Of course, there's other inert gases that you find. Yes?
It's probably a really dumb question, but is that all the elements? Or is that just...
Yeah, those.
No, that was printed in 1991. So there's quite a few more elements that should be on that table. But this is good enough for this level.
So they
We're
knew
not
there
college
was more,
chemists.
But they just hadn't found a way to discover them yet?
No, they just had
They didn't know how to classify them is what I would say. But anyway, let me get this wrapped up so we can just look at just a little more content. But anyway, so when we look at this, you said nitrogen, 14, it's 14.01, but these are what we call diatomic molecules because they just do not exist in nature alone, okay? Oxygen can, but it's way up in the Earth's atmosphere where a lot of different types of reactions are taking place to make ozone. And you've heard of ozone, right? Because ozone is this, okay? So when you get that odd number, that means some of these oxygen atoms have to be breaking apart so they can combine with other oxygen atoms. But the idea is, what is 14 plus 2? Oh, I'm sorry, 14 times 2. I was going to look at you like you're idiots when you told me 16, but I gave you the bad information. 14 times 2 is what? 28. What is 16 times 2? So, which one has the bigger number? 32. Oxygen. That is why oxygen is lower in the Earth's atmosphere, and that is why we run on oxygen and not nitrogen. Okay? What's that?
If there was no oxygen, like nitrogen
If
was lower, would we
nitrogen
run on
weighed
nitrogen?
more, would we be able to?
I don't believe so, because have we heard of something called the bends? The bends is when you go way down below the ocean's surface of the water, and that pushes a lot of nitrogen gas into your bloodstream. And when you come to the surface, where's the pressure greater, at the surface or down below? So when all that nitrogen gets pushed from your body tissues, hang on, into your blood, you're going to have your hand up there for a little bit, pushes it from your body tissues into your bloodstream. So what do divers do? Do they shoot up really fast? They go really, really slow, and as that pressure goes down, that nitrogen is released from your body tissues into your bloodstream, and you just exhale it. Yes?
If nitrogen, wait,
What if you go up?
It would just be the way the man upstairs would have had to design this many, many, many years ago. Yes, quickly. Quickly.
So with the nitrogen and the water, like, I thought nitrogen was up here and then oxygen and then the water, but like, how much is in water?
But you can put gases in water, because these ding-dongs back here, whether it's a bottle or a can, you open this and what do you hear on a can? There's gas inside of there. So you can get gas into liquids. Yes?
How?
You compress it. Yes?
Divers breathe like a mixture of oxygen and helium and that stuff so that it makes it easier for it to come out, right?
Could be. I'm not sure on that. But is it a good question?
yeah.
Okay.
Why does helium make your voice higher?
Because it has something to do, we could say, the resonance on the wavelength of the voice as it comes out. Because you can change your voice if you put a little bit of stress on your voice box. It changes the frequency. So when you crank it like this, it changes your voice. See, that you're doing the same thing. Yes, quickly.
What would happen if you went up too fast when you like?
It's going to affect your nervous system, and you're going to have lots of problems. Yes, quickly.
Okay, nitrogen is light, right? Then how is it like down here if it's light? Because it goes oxygen and nitrogen. So then how is it in like,
It's lighter, so it's further up in the atmosphere.
so then how is it in like bottles and like?
It has to be in a closed system. Okay, so if this cup was a closed system, you can have even a tube shooting gas in there because it's closed. Then once you're done, you seal that, just like cans and bottles, and then once you open that, that gas gets released.
So then how does the ocean have nitrogen?
I suppose different ways that organisms break down from amino acids and proteins that are found. A lot of it's probably from nitrates, which is NO3 molecules. Anyway, moving forward. Okay. So I think, we just want to do this first slide here. So scientific shorthand, okay? So a way you can make reference to that, and this drives me nuts when my wife does it. Oh, I hate this, okay? Let's say, for instance, if I sent her a text message and she replies back, "Are you staying for the game?" Now, a common person would say A-R-E space Y-O-U space staying for the game. But that might not be how the message comes across.
R space.
Letter R space U space staying for the game.
Oh, I don't even put a space in it.
I'm not going to say that word starts with an R. Just use your imagination. It's a synonym for stupid. It's a very mean term for stupid. That's what I would say that is. Okay, so you could say that the letter U, which stands for Y-O-U, is a shorthand. Now, sometimes autocorrect probably takes care of that, but that's an example of what shorthand is. Okay, why would it be important to learn some of this? Well, for some of you that, again, want to go into the scientific field, South Dakota State has these commercials which is saying for you to be you or explore your options or whatever, if you pay attention to the background, they show a whiteboard of probably a biochemistry class where they show all of different chemical formulas up on the whiteboard. And you'd be right to be asking and questioning this. Why are we writing this down when a computer does all this? Good question. But one of the things that scientists like to be able to do is replicate things. So when you write that down, chances are, yeah, you might put it into a computer and store it there, which is fine and dandy. But sometimes it's just better to have that lab notebook so you have access to it right then and there, and you can replicate things. This would be an example right here. For some of you who go on and take the organic and biochemistry class here, we make hand cream. Okay? Through trial and error with this lotion, okay, we write it down so we can replicate that from year to year. And it turns out pretty good. The problem with it, though, is it's maybe a little greasy, and it may not smell as good as what you think your lotion does. But its functionality is really, really good. It does its job that moisturizes your skin. It just doesn't have the characteristics that you like for spreadability, the smell, the greasiness that it leaves behind. But other than that, that's why you write things down as a scientist, so you can replicate that. Although I'm not going to give myself a whole lot of credit with that I don't know if I'm really a scientist. Although that's what my profile page says for guessing on ESPN for football games. I'm the mad scientist. Wah, but I'm not doing very good. But anyway, okay, so elements have 1- and 2-letter abbreviations. So I'm going to, just for about a minute or maybe 2 minutes, okay? Okay, 1 letter. What element is that? Oxygen. Okay, we saw carbon, we saw nitrogen, okay? So there's 2 letters. What might that be? No. Chances are, going off of that, it's nickel. Chances are, when you look at these 103 elements that were known back in 1991, probably 80% of them, I don't know what the percentage is for sure, probably start with the first letter for sure, and then have the second letter. That's not always the case, okay? You wouldn't know this, but it's a color blue, like this. Cobalt blue, okay? Okay? Any ideas? Nope. Bromine, okay? You like your salt, right?
Salt.
Calcium.
No.
Sodium.
Nope.
I know this one.
Potassium.
Chlorine.
Here's an exception, okay? This is actually called niobrenium, I think. This is Latin, niobrenium, for sodium. So we don't use this for sodium because that's sulfur. You don't use this for sodium because that's selenium, okay? You don't use this for sodium because that's tin, okay?
10.
Yes.
Stannate is Latin for tin.
I really don't get this.
Okay? So when we look at this, this is just one of the things that you're going to learn in this chapter. Okay? This is highly, highly volatile. Sodium is very explosive. Okay? When it's in its raw form. This, just look at World War I and its history. That is very, very toxic and poisonous to the human body.
Mustard gas.
Mustard gas, which is pure chlorine.
Oh, it's
Okay? But when you put sodium and chlorine together, you get sodium chloride, known as table what?
salt.
Table salt. So what happens is you can change and manipulate some of these properties of these elements.
Bags just make it good. There's chlorine in salt.
Okay, that's all I have. We'll catch up to you next time.
If I mix